A circular coil of a wire consisting of 100 turns, each of radius 8 centimeter, carries a current of 0.40 ampere. This is the problem. What is the magnitude of magnetic field B at the center of the coil? 4.1. A circular coil of wire consisting 100 turns. Number of turns is number of turns. Just 100 turns. Each of radius 8 centimeter. Radius is equal to 8.0 centimeter. Carries a current of, that is I is equal to 0.40 ampere. What is the magnitude of the magnetic field B at the center of the coil? At the center of the coil. They have given a circular coil, single coil, right? For a single coil, the radius of this single coil is R. The current flowing in this coil is I. How to calculate the magnetic field at the center of the coil? Formula magnetic field at the center of the coil. B is equal to mu naught I divided by 2R. For a single coil, the expression of the magnetic field B is equal to mu naught I divided by 2R. 2R. This is for what? Single coil. ಎಷ್ಟು ಟರ್ನ್ಸ್ ಇದಾವಲ್ಲಿ 100 ಟರ್ನ್ಸ್ ಆದ್ರೆ ಹೌದಾ 100 ಟರ್ನ್ಸ್ ಇದಾವೆ ಅದನ್ನ ಆಮೇಲೆ ಏನು ಮಾಡ್ತೀವಿ ನಾವು ಇಂಟು ಅದಕ್ಕೆ 100 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು the magnetic field due to current carrying circular coil single coil what is the value of mu? We can convert this expression into v is equal to multiply I divided by 2 pi. This is multiply and divide by 2 pi ಮಾಡಿದ್ರೆ mu naught divided by ಇದೇನಾಗ್ತದೆ I 2R into 2 pi divided by 2 pi. That is equal to mu naught 4 pi into 2 pi I divided by. We know the value of what? Mu naught divided by 4 pi. So 10 to the power minus 7 into the value of 2 pi value is 3.142 and current is 0.4 whole divided by the radius is it is in terms of centimeter therefore 8 into 10 to the power minus 2 meter 8 into 10 to the power minus 2. This is for a single coil. Two into 3.142 into 0.4 ಎಷ್ಟು 2.51 into 10 to the power minus 7 divided by 8 into 10 to the power minus 2. V is equal to 2.5136 divided by 8. 0.314 into 10 to the power minus 5. This is for single term. ಎಷ್ಟು ಟರ್ಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು 100 ಕೊಟ್ಟಿದ್ದಾರೆ. for 100 term magnetic field is equal to 100 into this is total magnetic field into V. 100 into 0.314 into 10 to the power minus 5. 100 under 10 to the power 2. 10 to the power 2 into 0.314 into 10 to the power minus 5. So this becomes 0.314 into 10 to the power minus. What is the unit of magnetic field? ಅದು ನಾವು 3.14 into 10 to the power minus 4 ಟೆಸ್ಲಾ ಕೂಡ ಅಂತ ಬರೀಬಹುದು. 3.14 into 10 to the power minus 4. Next question 4.2. A long straight wire carries a current of 35 ampere. What is the magnitude of the field B at a point 20 centimeter from the wire? 4.2. A long straight wire carries a current of 35 ampere. Long straight wire carries current is to 35 ampere. What is the magnitude of field B at a point 20 centimeter from the wire? R is equal to 20 centimeter. ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ರು. ಫಾರ್ಮುಲಾ ಏನು ಕೊಟ್ಟಿದ್ರು? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಅ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಸ್ಟ್ರೈಟ್ ವೈರ್ V is equal to mu naught I divided by 2 pi R. divided by 2 ಮಾಡ್ಕೊಳ್ಳಿ equations ಗೆ ಏನಾಗ್ತೈತೆ ಇದು mu naught divided by 2 into 4 pi 2I divided by r. The value of mu naught divided by 4 pi is 10 to the power minus 7 into 2. Current ಎಷ್ಟು ಹೋಗ್ತಾ ಇದೆ I is 35 ampere and distance is 20 centimeter, means 20 into 10 to the power minus 2 meter. 20 into 10 to the power minus ಎಷ್ಟಾಗ್ತೈತೆ ನೋಡಿ ಇದು 70 divided by 20 ಎಷ್ಟು 3.5 into 10 to the power minus 5 unities Tesla. So this is the magnitude of magnetic field at a point P due to this current carrying straight line. This magnitude ಬಂತು ಹಾಗಾದ್ರೆ ಡೈರೆಕ್ಷನ್ಸ್ ಅನ್ನು ಹೇಳಬೇಕಂದ್ರೆ ಏನು ಹೇಳ್ತೀರಾ to get the direction of the magnetic field we use the right hand rule. Right hand rule ಪ್ರಕಾರ ಈಗ ಕರೆಂಟ್ ಅಪೋರ್ಡ್ ಇದೆ ಪೊಸಿಷನ್ ಈ ಕಡೆ ಇದೆ ಅಂದ್ರೆ ಡೈರೆಕ್ಷನ್ ಈಸ್ ಇನ್ವರ್ಡ್ ಕ್ರಾಸ್ ಸರ್ಕಲ್. ಫಸ್ಟ್ ಅನ್ನೋದು ಕರೆಂಟ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಫ್ಲೋ ಆಗಕತ್ತಿತ್ತಂದ್ರೆ ಔಟ್ವರ್ಡ್, ಕ್ಲಾಕ್ ವೈಸ್ ಫ್ಲೋ ಆಗಕತ್ತಿತ್ತಂದ್ರೆ ಇನ್ವರ್ಡ್. 4.1. Next 4.3. The problem is a long straight wire in the horizontal plane carries a current of 50 ampere in a north to south direction. Give the magnitude and direction of magnetic field at a point 2.5 meter east of the wire ಅಂತ ಕೇಳಿದರು. A long straight wire in the horizontal plane carries a current of 50 ampere in a north to south direction. This is 4.3 north, south, east, west. Carries current of 50 ampere in north to south direction. So the current flow ಆಗ್ತಾ ಇದೆ, ವೈರ್ ಇದೆ, ನಾರ್ತ್ ಟು ಸೌತ್ ಏನು ಫ್ಲೋ ಆಗತೈತಿ, ಕರೆಂಟ್ ಫ್ಲೋ ಆಗತೈತಿ. ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ? I is equal to 50 ampere. 50 ampere. Give the magnitude and direction of magnetic field at a point 2.5 meter east of the wire. ಹಾಗಾದ್ರೆ ಈ ವೈರ್ ಇಂದ ಈಸ್ಟ್ ಡೈರೆಕ್ಷನ್ಸ್ ಗೆ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್? 2.5 meter east of the wire. Magnetic field ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಾರೆ. ಸೇಮ್ ಫಾರ್ಮುಲಾ ಹಚ್ಚಿರಿ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿ. B is equal to directly formula ಮಾಡ್ತೀನಿ. B is equal to mu naught divided by 4 pi 2I divided by R. The value of mu naught divided by 4 pi is 10 to the power minus 7 into 2. The current is 50 divided by the value of R is 2.5. 100 divided by 2.5. ಎಷ್ಟು 40 into 10 to the power minus 7 Tesla. Direction, current is downward, outward. At this point, the direction of the magnetic field is outward. ಇಲ್ಲಿ ಇನ್ವರ್ಡ್ ಇರೋದ್ರಿಂದ next 4.4. The problem is a horizontal overhead power line carries a current of 19 ampere in east to west direction. What is the magnitude and direction of magnetic field due to current 1.5 meter below the line? So ಈಗ ವೈರ್ ಅನ್ನ ಏನು ಮಾಡಿದಾರ ಈಸ್ಟ್ ಟು ವೆಸ್ಟ್ ಡೈರೆಕ್ಷನ್ಸ್ ದಲ್ಲಿದೆ. ದಿಸ್ ಇಸ್ ದಿ ವೈರ್. ಅಂದ್ರೆ ಈ ಪೋಲ್ ಟು ಪೋಲ್ ಕಟ್ಟಿರ್ತಾರಲ್ಲ, ಎಲೆಕ್ಟ್ರಿಕಲ್ ಪೋಲ್ ಟು ಪೋಲ್ ಮೇಲ್ಗಡೆ ವೈರ್ ಕೊಟ್ಟಿರ್ತಾರಲ್ಲ, ಈಸ್ಟ್ ಟು ವೆಸ್ಟ್ ಡೈರೆಕ್ಷನ್ಸ್ ಇದೆ. ಇಲ್ಲಿ ಈಸ್ಟ್ ವೆಸ್ಟ್ ಗೆ ವೈರ್ ನ ಇಟ್ಟಿದ್ದಾರೆ. ಕರೆಂಟ್ ಎಷ್ಟು ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅವರು? ಕರೆಂಟ್ ಈಸ್ flowing 90 ampere in east to west. East ಇಂದ ಕರೆಂಟ್ ಇದರಲ್ಲಿ 90 ampere ಫ್ಲೋ ಆಗುತ್ತೆ. Ampere. What is the magnitude and direction of the magnetic field due to the current 1.5 meter below the line? ಹಾಗಾದ್ರೆ ವೈರ್ ಇಂದ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್? 1.5 ಮೀಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ದಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟು ಅಂತ ಕೇಳ್ತಾರೆ. ಯಾವ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ತೀರಾ? B is equal to mu naught divided by 4 pi 2i divided by r. That's B is equal to mu naught divided by 4 pi 2i divided by r. The value is 10 to the power minus 7 into 2. The current is here 90 amperes divided by the distance is 1.5. That is equal to 180 divided by 1.5. Is to 120. 120. 150 or 130 na? 20. 120. 120 into 10 to the power minus 7 Tesla. What about the direction? ರೈಟ್ ಹ್ಯಾಂಡ್ ರೂಲ್ ಪ್ರಕಾರ ಕರೆಂಟ್ ಹಿಂಗೆ ಹೋಗ್ತಾ ಇದೆ, ಪೊಸಿಷನ್ ಕೆಳಗಡೆ ಇದೆ, ರೈಟ್? ಸ್ವಲ್ಪ ಬೆಂಡ್ ಮಾಡಿದ್ರೆ ಔಟ್ವರ್ಡ್. The next question is 4.5. What is the magnitude of magnetic force per unit length on a wire carrying a current of 8 ampere and making an angle of 30 degree with the direction of uniform magnetic field of 0.15 Tesla? 4.5. What is the magnitude of magnetic force per unit length on a wire carrying a current of 8 ampere, making an angle theta 30 degree with the direction of the uniform magnetic field? Uniform magnetic field idele current carrying conductor ಎಷ್ಟು angle ಮಾಡ್ತಾ ಇದೆ? So this is making an angle theta is equal to 30 degree with the magnetic field. The strength of the magnetic field is how much? Strength is pretty low, 0.15 Tesla. And the current flowing in this wire is I is equal to ಎಷ್ಟು? That is 8 ampere. How to calculate the magnitude of the force per unit length? We have to calculate a force per unit length of this wire inside this uniform magnetic field. When we place an electric current or a current carrying conductor inside the uniform magnetic field, it experiences the magnetic force, and the expression of that magnetic force is F is equal to I L B sin theta. और ಏನು ಕೇಳಿದಾರೆ ನಮಗೆ ಫೋರ್ಸ್ ಪರ್ ಯೂನಿಟ್ ಲೆಂತ್ ಕೇಳಿದಾರೆ, ಹಾಗಾಗಿ L ಅನ್ನು ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ this is the expression of force. They asked to find force per unit length, ಹಾಗಾಗಿ F divided by L is equal to I B sin theta. The value of I is 8. The value of magnetic field is 0.15 into sin 30. What is the value of sin 30? 1 by root 1 by 2. That is equal to 8 into 0.15 into 0.5. This becomes 4 into 0.15. Is it 0.6? Ashana? Okay. Unit is Newton per meter. 0.6 Newton per meter. Per unit length, the force on that current carrying conductor is 0.6 Newton. To get the direction of the force, we use a Fleming left-hand rule. Remember, because if the current is flowing in the upward directions, the magnetic field, the current is flowing in the upward direction, and it experiences a force inward. Temporarily, other current now downward magnetic field, the flow of current, and direction of the magnetic force, that is outward. In case current ಏನಾಗ್ತಾ ಇದೆ ಅಪ್ವರ್ಡ್ ಹೋಗ್ತಾ ಇರೋದ್ರಿಂದ ದಿಸ್ ಕಂಡಕ್ಟರ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಅ ಫೋರ್ಸ್ ಇನ್ ಅನ್ ಇನ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್. ದಿಸ್ ಇಸ್ ದಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿ ಫೋರ್ಸ್ ಪರ್ ಯೂನಿಟ್ ಲೆಂತ್. Next question. 4.6. The question is, a 3.0 centimeter wire carrying a current of 10 ampere is placed inside a solenoid perpendicular to its axis. The magnetic field inside the solenoid is given to 0.27 Tesla. What is the magnetic force on the wire? Solenoid is there, 4.6. Solenoid. When we flow electric current through this solenoid, what happens? We can observe the magnetic field inside the solenoid. This is the magnetic field, the uniform magnetic field. And this one is the axis of the solenoid. ಈ axis ಗೆ ಏನು ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅವರು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಒಂದು ವೈರ್ ಅನ್ನು ಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. A 3 centimeter wire carrying a current of 10 ampere is placed inside a solenoid perpendicular to its axis. ಈ axis ಗೆ perpendicular ಆಗಿ ಒಂದು ವೈರ್ ಅನ್ನು ಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಈ ವೈರ್ ದು ಲೆಂತ್ ಎಷ್ಟು? 3.0 centimeter. ಎಷ್ಟು ಕರೆಂಟ್ ಅನ್ನು ಫ್ಲೋ ಮಾಡ್ತಾ ಇದ್ದಾರೆ? I is equal to 10 ampere. ಹಾಗಾದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಎಷ್ಟಿದೆ? Solenoid is given to be 0. The strength of the magnetic field produced by this solenoid is 0.27 Tesla. What is the magnetic force on the wire and paper? Magnetic force on the wire. The expression is F is equal to I L B sin theta. Here in this case the theta is 90 degree. That is angle between length and magnetic field. Magnetic field ಹಿಂಗಿದೆ, length ಹಿಂಗಿದೆ, ಹಾಗಾಗಿ ಒಬ್ಬರ ಮಧ್ಯೆ angle 90 degree ಬರ್ತದೆ. Therefore the value of I is 10, the length is 3 centimeter, 3 into 10 to the power minus 2. The strength of the magnetic field is 0.27 and the value of sin 90, that is equal to 10 into 3 is 30 into 10 to the power minus 2 into 0.27. What is the value of sin 90? 30 into 0.27. ಎಷ್ಟು? 8.1 into 10 to the power minus 2 Newton. So in this case, the direction of this force is, magnetic field is in this direction, the current is flowing upward, therefore this current carrying conductor experiences a force inside or inward cross with sun. Then do 4.6.